Section 5.2, common factors. So some vocabulary we're going to have is greatest common factor, or the GCF. This is the largest factor shared by two or more terms. For example, the greatest common factor of 12 and 28 is 4. This can be found using a factor tree. So the factors of 12 are 3, 4, and then you have 2 and 2. And then for 28, you have 7, 4, and then the 4 also turns into 2 and 2. But since you want the greatest, you go with the larger number, which is 4. 4 is the only thing common in 12 and 28. You're also going to need to know the least or lowest common multiple, LCM. The smallest multiple shared by two or more terms. So the multiples of 6 and 8 are 24, 48, 72. The lowest common multiple is 24. This can be found by writing out the multiples of each term. So for 6, you have 12, 18, 24, 30, 36, 42, and 48. For 8, you have 8, 16, 24, 32, 40, and 48. So the lowest number in each of these lists that's the same is 24. Example 1, determine the greatest common factor. So there's a method 1 is prime factorization. So we have 16x squared y and 24x squared y squared. So you're going to list the prime factors of the numerical coefficients, so the numbers. So we have 16 and 24. The prime factors of 16 are 2, 2, 2, and 2. So it would be like saying 2 times 2 times 2 times 2. 24, the prime factors are 2 times 2 times 2 times 3. So we can see that each of these has 3 2's. So the numerical greatest common factor is 2 times 2 times 2, which is 8. Now listing the prime factors of the variables, or your letters, we have x squared and y. So when we see we have x squared, we know we have 2 x's, and then we're multiplying by a y. We have x times y. Then we have x squared y cubed. We have x times y times y times y. So looking at what's the same, they both have 2 x's and at least 1 y. So our variable greatest common factor is x squared times y. This is because x times x is x squared. So therefore, the greatest common factor of the terms 16x squared y and 24x squared y cubed is 8x squared y. Method 2, listing the factors. So write the factors of each term using the same terms, 16x squared y and 24x squared y cubed. We have 1, 2, 4, 8, and 16 for our numerical coefficient. Then we have x squared, and y. 24, x squared, y cubed. 1, 2, 3, 4, 6, 8, 12, and 24. X squared, y squared, and y cubed. Now, the reason that we have our x squareds and y cubed in here is because x squared times 1 is x squared, and y cubed times 1 is y cubed. So looking at what's the same in each list, we see we have an 8, an x squared, and a y. So the greatest common factor is 8x squared y. So example number 2, write a polynomial in factored form. So that's looking at 7a squared b, take away 28ab plus 14ab squared. So we want to know what the greatest common factor for each numerical coefficient is. So that's like using your prime factorization, which we just did. So factors of 7, 1 and 7, so we don't include the 1. 28, our factors are 2 times 7, and 14 is 2 times 7. So we notice that 7 is common in all coefficients. You will need to have this number for the answer. Then you need to identify the greatest common factor of the variables. So we have a squared b, So a times b, ab, which is a times b, ab squared, which is a times b times b. So we notice that there is an a times b in both. So ab is the greatest common factor. Once you find these, you need to divide each term by the greatest common factor. So we have 7ab squared b, take away 28ab plus 14ab squared. Divide that by 7ab. Now I broke it down into parts. 7a squared b divided by 7ab leaves you with an a, because what you do is your 7's cancel out, your b's cancel out. Now it's like a squared divided by a, and we know that when we're dividing the same base, we take away. So it's like 2 take away 1, which equals 1. So we're left with a. That goes over here. 28ab divided by 7ab. B's cancel out, a's cancel out. 28 divided by 7 equals 4. Now since the 28 is negative, we're going to have a negative 4. Now we have 14ab squared divided by 7ab. A's cancel out. 14 divided by 7 equals 2, and b squared divided by b equals b. So we have 2b, which goes up here. And that would have been our answer. So our answer is the term you divided by, so your greatest common factor, times your a, which you got from here, your negative 4, which you got from here, and the fact that 28 was negative, and then we're adding in our 2b, which we got here. Example 3, determine binomial factors. So you're going to write the expression in factored form. For question A, we have 3x times x take away 4 plus 5 times x take away 4. So the greatest common factor here is x take away 4. You can see this easily when polynomials are written in this form. So what we're going to do is divide by the common factor. So we have x take away 4 is common in each. So if we have 3x times x take away 4 divided by the common factor of x take away 4, these cancel out and we are left with 3x. Now here we have 5 times x take away 4. Same thing, and we are left with 5. So we just divided and found what remained. So our factors are 3x, this is positive, so plus 5, and then we multiply it by our x take away 4. Sorry for going back and forth, I just lose my train of thought. So a greatest common factor can be found by grouping terms. So we have y squared plus 8xy plus 2y plus 16x. So all you're doing is you're grouping the first two terms and the second two terms. Y squared plus 8xy plus 2y plus 16x. So we're just going to look at this half for now. You can see that there's a y common in both, and that's it. So you can divide by y. That leaves you with y times y, because y squared divided by y is y, plus 8x, because we're just getting rid of that y. You can do the same over here. You can see the only thing common here is 2. So you pull out your 2, and you multiply it by your y plus 8x. Now, your one term will be y plus 8x, because that's common in both. And then you're just going to put these terms together, which is y plus 2. So your factors are y plus 2 times y plus 8x. Example 4, using greatest common factor to solve a problem. So Paula has 18 toonies, 30 loonies, and 48 quarters. She wants to group her money so that each group has the same number of each coin and there are no coins left over. So A, what is the maximum number of groups she can make? B, how many of each coin will be in each group? And C, how much money will each group be worth? We're going to look at A first. So we need to identify the greatest common factor of 18, 30, and 48. So the factors of 18 are 1, 2, 3, 6, 9, and 18. How I find my factors like this is I go 1 and 18, because 1 times 18 will give you 18. I know 18 is divisible by 2, and I know my 2 times 9 is 18. 18 can be divided by 3, and that is 6. It can't be divided by 4, it can't be divided by 5, and then 6 is already here. So then I just list 1, 2, 3, 6, 9, 18. I go from smallest to largest just because it's easier. So then factors of 30, following the same process. 1, 2, 3, 5, 6, 10, 15, and 30. And then the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So the common factors are 1, 2, 3, and 6. So the highest is 6, so that means the greatest common factor is 6. Therefore, the maximum number of groups is 6. So that is your answer to A. The maximum number of groups is 6. Now, for B, we want to know how many of each coin will be in each group. So what we do is there are 18 toonies. 18 toonies divided by 6 groups means that there are 3. 30 loonies divided by 6 groups is 5. 48 quarters divided by 6 groups is 8. So that means that there will be 3 toonies, 5 loonies, and 8 quarters in each group. And finally, we want to know how much money each group will be worth. So you multiply the number of each coin by the value of each coin. So for toonies, we have 3 of them that we found out in the last question. Toonies are worth $2, so then we'll have $6 worth of toonies. Loonies, we have 5 of them, times $1 is $5. And quarters are $8 times 0.25, because that's how much a quarter is worth. And that gives you $2. Then all you do is you add those together. So you have 6 plus 5 plus 2, that gives you 13. So each group will have a value of $13.